The gravitational potential is an alteration of space around anything that has mass. The gravitational potential is a scalar field. That means it has only a magnitude at every point in space. Finally, the units of gravitational potential are joules per kilogram. This is the equation for the gravitational potential of a point particle. It depends on the gravitational constant, the mass of the point particle, and the distance from the point particle to the position where the gravitational potential is measured. It follows that the gravitational potential of a point particle at a position P, that is a distance d away from the point particle, is negative g times the mass of the point particle divided by d. The gravitational potential of a system of two point particles is the summation of the gravitational potentials of each of the point particles in the system. Since the gravitational potential is a scalar function, the distances from the point particles to the position P, but not the orientation of the particles, is important for the summation. These distances can be found, if necessary, using trigonometry. For this system of point particles, the expression for the gravitational potential includes three terms, one for each of the point particles in the system. Two of these terms are identical, because two of the point particles in the system are at the same distance from the position P. Since the gravitational potential is a scalar function, the gravitational potentials of each of these systems of identical point particles at the positions P are the same. In other words, the orientation of the point particles does not matter for the calculation of the gravitational potential. All that matters for this calculation are the masses of the point particles and the distances from these point particles to the positions where the gravitational potential is measured. For systems consisting of a large number of point particles, the gravitational potential is the linear summation of the contributions from the gravitational potentials of each of the point particles in the system. We can write this summation in a simpler form using the summation symbol and an index variable, in this case the variable I, which denotes each particle in the system.